Hello and welcome to Mr. Wiley Teaches Math. Today we're going to be developing and working with formulas. So we're going to be working with equations again, and we're going to be starting with the patterns. They're going to be often displayed as tables, and working to write an equation, a general rule for the pattern. This is very helpful when we need to find the solution higher up or further along in the pattern. So our first example, we have a chart that has hours and costs. We're going to give each of these a variable. Hours we'll call H, and costs we'll give a C. And we see that for the first hour, the cost is 24. Let's put some units in there, $24. One was 12, 2 is 24, 3 is 36, 4 is 48. I can see going down that it's increasing by 12 each time, which might be useful to know, but it's not really the pattern I'm looking for. I'm looking for going across the table. What's the pattern between 1 and 12? Well, I could say I'm adding 11. 1 plus 11 is 12. Let's check that next one out. 2 plus 11 is 13. Okay, my pattern doesn't work there. It has to be a different explanation. Let's try multiplied by. It's 1 times 12. Let's see if that works each time. 2 multiplied by 12 is 24. 3 times 12 is 36. 4 times 12 is 48. That works each time. It's a multiplication. Right. So I'm going to write a formula. If I'm looking for the cost is equal to 12 times the number of hours. Cost is equal to 12h. And I got that from seeing the pattern going across. Even though this is a really simple pattern, it could be very useful if someone said, well, for 50 hours, what's the cost? If I didn't see the pattern, I'd have to add 12 each time, go all the way down, do that 50 times, and eventually get the solution. Or I can use my general rule, my equation, and find out. So the cost, and let's make it when h is 50. So the cost is equal to 12, in this case times 50, do the substitution. 12 times 5 is 60, add the 0, 600. So therefore, the cost will be $600. For our second example, we're working with perimeter and the number of squares. So let's call the number of squares. Let's just choose a variable. Let's choose n for number. And perimeter, that's usually a large P. We'll go for that. So the number of squares and then versus perimeter. Again, I can go down and say, hey, it's plus 2 each time, 4 plus 2, plus 2, plus 2. But that's not really the pattern I'm looking for. I'm looking for going across. So it could be plus 3, 1 plus 3 equals 4. 2 plus 3 is 5. Okay, that didn't work. 3 plus 3 is not 8. Okay, it's not working. What else could I do? I could multiply by 4. 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. Hey, it's not working. Only worked for the first one. Well, what else could it be? So I'm looking for, it could be 2 times the number plus 2. Little combination here of things, of variables. So 1 times 2 is 2, plus 2 is 4. Okay, that worked. Let's put 2 in here. 2 times 2 is 4, plus 2 is 6. 2 times 3 is 6, plus 2 is 8. Hey, that seems to be working. So it looks like the perimeter is equal to 2 times the number of squares plus 2. There's my general rule or equation for this. That'd be really useful if someone came along and said, hey, if you got 250 squares, what's the perimeter? Well, now I'm just going to substitute in whatever number I'm given. Let's say 250. So 250, 2 multiplied by 250 plus 2. Again, I could have got that by going down and adding 2 each time and doing that 250 times and eventually getting to the answer, but this should be a little bit quicker. 2 times 250 is 500 plus 2. Perimeter is 502. I didn't have any units on there, so I'm just going to leave it like that. Therefore, the perimeter is 502. I was able to do that because I found the pattern going across, not looking it down for between the same variable, but going between 2 and 6, 3 and 8. And it's really helpful when we had to go higher up in the pattern, like 500, 250. Now, if anyone chose any number, they said 1,363, what's the number of squares, what's the perimeter, you'd be able to do it because you have the general rule. Thanks for watching. Be sure to check the class website for additional information and examples.